Hi students. In this video we're going to go over how to create G-code for running a CNC machine from a Solidworks solid model. And we're going to use Fusion 360 to accomplish this. The first thing I want you to notice is that I have this part and it's got rotary features, it's cylindrical, but it also has this square shape on the top. Okay, this would be kind of difficult to do on a hand machine. The other thing I want you to notice is the orientation in the coordinate system. So X and Y are representative of where the milling table would be, and Z is in the direction of our tool. So if you can imagine, we're going to have some cutter that comes down and clears out that pocket. You want that cutter to be parallel to the Z-axis. If that's not the way you drew your model, what I would recommend is that you create an assembly, bring your part in as a component, and then export that part as a Step 203 file. Because I have mine properly aligned, we can go directly to the Step 203 exporting step. Step 203 is a file interchange format that was developed by NASA so that different CAD systems could talk to each other. To do it in SolidWorks, we're simply going to say File, Save As, and instead of Part, we're going to choose Step 203 right up here. And I'm going to call it Test Part 2 and put it on my desktop. And I'll hit Save. So now here's my test part 2 right here. Okay, let's go over to Fusion 360. This is an Autodesk product. And the first thing we have to do is upload it into Fusion. So I've opened the program. I'm going to hit Upload. I'll select my file off the desktop. And let's see, we'll go down to test part 2.step, and we'll say open and upload. And for most of our parts, this shouldn't take very long. They're relatively small files. Okay, so our status is complete. We can hit close. And over here, we should see our test part 2. And here it is. I'm going to double click on that. And here's my test part. We'll get rid of this file dialog box so I can maximize the screen. And over here, we have our design functions box. I'm going to come down to manufacture, and this is where we're going to be allowed to create our G-code. I'm going to change the units to inches just because I drew it as an inch part. Doesn't matter, you can mill in metric just as well as English, really doesn't matter. Okay, so under setup, it's being a little fidgety. Okay, let's go right on to our milling functions. So we have 2D milling functions and we have 3D milling functions. Most of what we're going to do is going to be 2D. 3D is when you get into fancy stuff like carving or faces that are constantly changing. Okay, so we're going to start off with a facing operation. And notice that Autodesk brings up a little representative picture of what's actually going to go on. Facing is something you're typically going to do in the beginning. It's going to flatten your material and it's going to give you a zero reference face to machine the rest of your part from. So I'm going to click Face, and my dialog comes up. The first thing I need to do is choose a tool. So what tool am I going to use? What's my cutter? I'll choose All. I'll choose the operation. So we're going to do facing. I'll say OK. These are the tools that are commonly used for facing. I want to use a flat 1/4 inch end mill. So I'll say OK. And the program automatically gives you the tools that are appropriate for that operation. I'm going to pick a 1/4 inch flat 2-flute end mill, and I'll say OK. And notice you can see the 1/4 inch end mill, and you can see the holder for the end mill up here, which is kind of jazzy. Okay, we're going to set our spindle speed. We're going to imagine we're doing this in the Crosby machine shop on the Tormach. 4,500 RPM. If I don't select anything else, it's going to face off the entire top of the part. We can modify that if we want. So I'm right-clicking. I'll hit Edit. I'll choose the geometry. And notice it faced off just slightly above the part. I think I'd rather have it face directly on this surface right here, this top surface. So I'll choose that top surface. We're going to set our heights. And this is where we get into things like clearing any hold down fixtures, stuff like that. So our bottom height, I like to work from the bottom of this menu up. Our bottom height is going to be our model top with no offset. So that's the bottom of where the cut is going to be made. Our top height is going to be the stock top. Our feed height, this is when you just want to move across the top of the part. So we'll move across the top and we'll clear by 0.2 inches. That sounds good. The retract height, if I need to go over any hold down clamps. And the retract height, again, this is if you got to go over something really tall. Okay. I'll do that. That all looks good. I'll go on to the next one. The number of passes. Okay. So if my part were really deep down inside the piece of stock that I was going to use, I might want to go with multiple depths, and I could say only take off, say, 1/16 of an inch at a pass. I could do that. Let's see, and that all looks good. Stock to leave, this might be important. Maybe you're doing a roughing operation. Maybe you want to come in with some big solid tool, take off a lot of material, and then come back in with a finish tool. You could leave stock on intentionally and then just take a fine finish cut. So that might be important to you. And nothing here that we really need. So we'll say OK. Fusion thinks about it. And here is a preview of the path that it just created. Okay, not bad. Let's add another feature. So the general process is we keep adding features, or excuse me, machining operations to create all of the features that will then yield our final desired shape. I think the next one should be a 2D pocket. And let's clean off this shelf. Again, I'm just going to go right across these tabs in the top. So we're going to use the same 1/4 inch end mill, 4,500 RPM. The geometry, I clicked on the face, so it's going to clean off this face for me. I'll set my heights. Now notice my heights are not correct. This is the bottom of the cut right here, and it's not on the face that I want. So I'm going to again go from the bottom of the dialog to the top. Bottom height, I'm going to say right there. Top height, I'm going to select the height that I want. I'll do a selection on that edge. That'll be the top of my cut. This one I'll set at the top of the model and offset it by 0.2 inches up, so that's okay. The clearance height, we'll set this at the model top plus 0.4 inches. No red error messages, we're good to go. Passes, again, it's assuming stock to leave, so it's leaving some material for cleanup. I don't want that. What I do want, however, is to do multiple depths so I don't take off too much material at a pass. And I'm going to say 0.07 inches to take off on every pass. And I'll say OK. And there's a preview of the operation that's going to occur. So we've faced off the material. Now we've created this step. I've just clicked in the background. So now let's do the center bore. We're assuming a 1/4 inch end mill. This is a 1/2 inch hole. What we can do is we can orbit that tool around, just spin it right down in, and create any size hole we want that is greater than a 1/4 inch. Well, let's do that. We'll say 2D, bore, so that means go drill a hole with the end mill. First one looks good, 1/4 inch end mill, 4,500 RPM. Circular face selection, so I got to click on the face, and you can see the preview of what's going to happen. That looks pretty good. Now we got to set our heights again. Going to work from the bottom of the dialog up. This one I'm going to say model bottom so that I drill all the way to the bottom. The top height will be my model top. And then the retract height and the clearance height, those all look good. No stock to leave. And multiple passes. Step over of a 1/4 inch. This one I'm going to change the pitch to 0.07 inches. Didn't like that. So we'll go back and edit it. Okay, so it wasn't liking the multiple passes. There's our pathway. Let's try it one more time. That's a better looking spiral. So it's just going down in a little bit faster. Sorry about those errors. Okay, so that gives us this step, faces off the top, does the bore. Now we need to put in these kidney bean shaped pockets. So we're going to do a 2D pocket. And you can do multiple features at once in one milling operation. So again, we'll go right across, 1/4" tool, that's good. Geometry, I'm going to choose the bottom edges. There we go. Again, I will set the heights. So the bottom height will go from the model bottom. The top height, I'm actually going to do a selected contour on that. Let's get this up a little higher. So we'll do a selection. We'll select the top of that edge. The feed height, the retract height, those all look good. The passes, we're not going to leave any stock. We will do multiple depths. So let's make this 0.07 inches. And I'm going to click OK. It thinks about it, and there we go. We've generated our toolpath. And the last thing we need to do is cut this part out of the material. So that is typically done with a 2D contour. This is what I often use as my last step for cutting the material out. So 1/4" end mill, 4500 RPM. I need to select my contour. So I'm going to choose the bottom edge. And let's see. My heights, again, I'm going to start at the bottom. I'm going to go to model bottom so that it cuts all the way through to the bottom of my part. The top height, I'm going to say I want it to cut from the model top. And that all looks good. I do not want it to cut the whole thing in one pass. So we're going to go with multiple depths. And we're going to go with 0.07 inches. And there's a representation of what's going to happen. It's just going to keep spiraling down in until it cuts the material free. Okay, so that looks good. Now it would be really cool if we could simulate this and see what's going to happen. So let's do that. I'm right-clicking on Setup 1. I'm going to say Simulate. There's all my toolpaths. And I'm going to turn on the stock, and I'm going to turn off the toolpaths. If I press play, we can see exactly what's about to happen. We clean off the top. We clean off the shelf. Now notice, it looks like it's leaving some material. That's okay. That's where the kidney bean shaped cutouts are going to come. So those will get actually cut away. And go down another cut. Again, you do not want to take off all the material at one time. Do nice gentle cuts, and that will give you a much better surface finish, and it will be much more gentle on the cutting tool. Okay, you can see the edges come into view. We're on our last step down. There's our little kidney bean shaped cutouts. And all of that tall material is in the kidney bean shaped cutouts. So that's not a problem. That's all going to go away. There we go. We're cutting our bore. Now we start cutting out the kidney beans. Now if your part is really long and everything starts getting boring, you can come to the bottom and speed up the playback. I'm going to let it run for the sake of this video since you're seeing this for the first time. And each of the different operations has a different color in the progress bar. This is actually quite resource intensive, which is why you're seeing my video card flashing. And we just keep spiraling down. And that's it. Our milling operation is over. And we can check it out. That does look like our solid model. So now what we need to do is we're going to close out of this simulation. And we need to actually create the G-code. What I'm going to do is right click. Creating the G-code is called post-processing. I'm going to drag this window back over. So we need to give it information about what machine to write the code for. Right here, these are all kinds of different milling machines. The machine that we have is the Tormach. We've got to tell it where to send the code. In my case, I want to send it to the desktop. We always have to have a program number. So I'll make it 1002. And that's about it. And we just say post. I'm going to say put 1002 on the desktop. We'll hit save. And there is the actual code that I'm going to put on a flash drive and take over to the Tormach. You do sometimes have to manually edit this. You might want to change feed rates, something like that. But this is the code you're going to run. So you're going to go over to the Tormach. You're going to set the cutter right at the center origin, the program 000. And when you press play, it should do exactly what was in the simulation. Okay. Thank you for watching, and I hope this was informative.